right, 10.2, arithmetic sequences and series. This section and the next section after, I think you'll like because we're going to be doing more applying of these, of what you learned in 10.1. Okay. Yes, we're going to, as you see, we have a couple definitions, but they're mostly to help you in solving some of these. If you're someone who just like straight up working with numbers, hey, this section is going to be for you. So let's define a couple things. So the arithmetic sequence is a sequence in which the difference between successive terms is a constant. Okay, so if you're increasing or decreasing by the same value each time, that's an arithmetic sequence. And that value that you're increasing or decreasing by is what's called the common difference. As the definition says, that's constant. That is the difference between successive terms in an arithmetic sequence. Okay. Here's a pretty basic one. Determine the common difference and find the next four terms in the sequence. So what's happening here? That's not my pen. There it is. What's happening from here to here? You're going up by 31. 31. You're increasing by 31 each time. So your common difference is 31. Common diff is 31. Now let's find the next four terms. We're going to be adding 31 to negative 67. I'm going to write that next. 4, 31. To it, we're going to get negative 36, negative 5, 26, 57. You just kept adding 31 because that was the common difference. Now we're going to have to use something that you learned in section 1. So if you don't remember what the explicit or recursive formula is, look back at your notes from section 1. So we're going to find both the explicit and recursive formula. So we need to find the common difference first in order to do this. So common difference is negative 12 each time. So your common difference is negative 12. Okay. So that's important for both the explicit and recursive. So if I'm trying to write the explicit, I'm going to write a sub n equals whatever a sub 1 is. What's a sub 1? A sub 1 is 35. Okay. And then I'm going to do plus n minus 1 times d. D is negative 12. Let's distribute. We're going to get negative 12, well, not 21, negative 12n plus 12. And simplify, you're going to get negative 12n plus 47. That is your explicit formula. Now the recursive, remember how we write it. I'm going to put this in red. I kind of hover a little big with the explicit formula to hurt my space a little bit. We write a sub 1 first. A sub 1 is what? A sub 1 is 35. What is... So we have a sub 1 is 35. And then we're at comma, a sub n equals a sub n minus 1. And then what are we going to do to the end of it? Now, what we're going to do at the end of it, we got your common difference. What's your common difference? It's negative 12. So we're going to do a sub n equals a sub n minus 1 minus 12. Find a 38th term of the arithmetic sequence. Oh no, 38th? You're going to make us count 30, do this 38 times? No, I'm not. Because you're going to kind of do what you did in the last problem and find one of the formulas. So first we need to find the common difference. What do you get? 27, because you're adding 27 each time. Common difference is 27, so therefore if we use the formula, a sub n equals a sub 1, which you know is negative 29. What else do we know? Plus n minus 1 times d. You know d is 27. Now, what else do you know? You could simplify this formula, but that's being extra, and I don't feel like being extra today. So I'm just going to straight up put n for n. Since it's this 38th term, I'm going to put 38 in for n. Won't let me write. Why won't let me write? Equals a sub n. There we go. So we simplify that. Drum roll, please. You'll get 27 times 37 plus negative 29. You'll get 970 for a solution. So find d of the arithmetic sequence. So what's our formula again? A sub n equals what? A sub 1 plus n minus 1 times d. Now, there will be moments when it would make more sense if you used the recursive formula. You may have to do that sometimes. And some of the problems you could do either one. It's important for you to realize that. So, hey, if something's not working out, you should probably use the other one. But in this case, I'm going to try using the recursive formula. Actually, not recursive, explicit. My apologies. So I'm going to put 75 down. We know the 38th term is what? We know the 38th term is 56.5. And I need to solve for d. So if I subtract 75, we're going to get negative 18.5 equals 37d divided by 37. And what do we get? We get d is equal to negative 1/2. It's a little algebra for you. So this is a doozy of a problem. I'll write a sequence that has 6 arithmetic means between 12.4 and negative 24.7. So that means if I have 12.4, there's going to be 6 numbers. 1, 2, 3, 4, 5, 6, until we get to negative 24.7. Remember our lovely formula. That's our explicit formula. A sub n equals a sub 1 plus n minus 1 times d. Now, I don't know what d is. I need that in order to solve. In order to solve and find the sequence, I know that 6 numbers later from your original, which is 12.4, you're going to get the next number. But how many numbers total are there? There's 8 numbers. Because we go from 1, 2, when I say 1, I mean 1, 2, 3, 4, 5, 6, 7, 8. 8 numbers till we get to negative 24.7. Okay. Now, if you solve for d, what will d be? D will be equal to, go ahead and solve that algebraically. If you don't get this, you did something wrong, I'm sorry. But you should get negative 5.3. Okay? So, if we're using our formula, now we want to find all the other ones. You can just simply keep subtracting negative 5.3 to get to your other numbers. So your next numbers, I'm going to write our answer in blue. And that's going to be 12.4, which is the one I gave you. So you should get that one right. That's 7.1. Yay. 1.8. Yay. Negative 3.5. Negative 8.8. Negative 14.1. And negative 19.4. There you go. Now, if you want to add a bunch of numbers in a sequence together, I could have you write it all out, but that would be evil, and I'm not that evil. So you might think I am, but I'm really not. So luckily, I'm sharing with you these lovely formulas. Now, similar to what I was saying between the recursive and explicit formula, where one would make more sense than the other, that's going to be the case with these two formulas. So you need to write both of them down, because there's going to be times when you're going to have to do a lot more work to do one, or you can't do it at all. So it's good to have both in your back pocket, depending on what you're given in the problem. So go ahead, jot those down. We'll get back to it. We have a couple examples to go through here with regards to this. I would argue this first one here might be slightly more difficult than the second one. But first, what's the common difference here? So you keep going down by 18 each time. So your common difference is going to be negative 18. Now, I have no idea how many numbers there are. I can't do that in my head. I'm sorry. If you're disappointing me, I'm sorry. But I do know in order to find that, I know we have negative 455. I know the first term's 211. And I also know I have no idea what n is, which is what I'm solving for. And I know my b is negative 18. Keep in mind, it's negative 18 times that whole expression. Please don't think of it as adding or subtracting. Just a little friendly reminder. So if I distribute negative 18n plus 18 to 11, and we are going to combine, and we're going to get 229 there, 255, subtract 229, 229, and then I'm going to get negative 18n equals what? Be equal to negative 684, and then divide both sides by negative 18, and you will get n is equal to 38. So when we go use the formula, the one that makes the most sense is formula 1, because we can go in, s sub n is equal to 38 over 2, and what else does the formula say? It says parentheses a sub 1 plus a sub n. So a sub 1, we know, is 211, plus a sub n, which is negative 455. So 38 divided by 2 is 19 times what's in the parentheses. You will get an answer of negative 4,638. Ooh, what a number that is. Wait, I'm sorry. This should be a 6. 3, 6. My apologies. All right. Next, this one is a little easier as long as you use the second formula. You know it's 19th number, so it'll be 19 over 2. Parentheses 2. We know the first term is negative 19. We know we're dealing with n is 19, so it'll be 19. Minus 1. And then your d is you're adding what each time? Oh, you're going to be adding 42 each time. And that's going to give us 19 over 2, bracket negative 38, plus 18 times 42. And when you add that all together, you're going to get 6,820. And that's, of course, after you multiply by 19 over 2. We got ourselves a series here. All right, so what's going to be best for us is, I know the first term, right? First term, if I put 23 into this, I'm going to get 46 plus 3, which is 49. So your first term is 49. The last term, you're going to get 77. So what does that mean for us? So I can use that formula 1, that it's s sub n equals n over 2, parentheses a sub 1 plus a sub n. A sub 1, as we went over, is 49. A sub n is 77. And this is going to trip people up because you're going to think, oh, it's going to be this number minus this number. No, add 1 to that, because it's like if you were to count these down from count up from 23 to 37, you're going to end up getting 15, not 14. So your n is always going to be 1 more than if you were to subtract them. So it'll be 15 over 2 equals s sub n. And if you take care of this, what do you get? 945. Thank you for watching, and we'll see you in class. Bye-bye now.